Okay, so we're going back and we're doing a little bit of stuff that was taught in AB.
Oh my gosh, I remember that. Oh wait, no.
Yeah. Tiny little bit.
Yo, you remember that from AB last year?
Yeah.
Yeah, we definitely already learned this.
What is this? The image is small. The image is projected as a trapezoid, no? What am I supposed to do?
Just choose there's no audio.
Help. Oh, get rid of. Help is exit.
Doesn't look like a trapezoid to me.
Okay, I need you to change this, guys. I messed it up. Where are you sighing already?
Just move from side. Does it have anatomy after this?
Yeah.
Okay. Change the equation to this.
Why don't you just hit a normal?
All right. Ready?
Oh no.
That looks like convenient.
So this is a parabola. You guys know this from Algebra 2. Parabola with a y-intercept of
0 dose.
0 dose, facing
Down.
downward.
Yes.
Man, I remember my algebra too.
Yep. And it intersects at,
I don't know that.
oh,
Oh my gosh, wait, this
Like
is...
in 0.
for y. Yeah, I'm going to take out a negative 1/2. So it's x squared minus 4. Okay, so negative 2 and 2. Close, close. Okay, so this is asking you to find the area of the region bounded by that equation, the x-axis, which is right here, and x equals negative 1, which is right here, and x equals 2, which is right here. Okay, so I want the area of this section right here. Okay. How do we find the area of that section?
Good question.
Integral, yes. From?
Negative 2 to 2.
No, just from negative 1 to 2. Because
Oh, I see.
because it told me to start at negative 1. Otherwise, if it just said bounded by those two, we would want to go negative 2 to 2. Okay. Of the function, right? Negative 1/2 x squared plus 2. Yeah? Nothing unusual. And then we integrate normally, and we get negative 1/6 x cubed plus 2x, and go from negative 1 to 2. And then we just plug it in and leave it, if it's free response, we want to leave it unsimplified so we don't make additional errors, and make it negative 8/6 plus 4 minus 1/6 minus 2. Okay?
It's 2x. So that's
Yeah, and will you plug negative 1 in for x? Okay, questions? Easy?
Have you already done this?
Yeah, you already did this, right? Okay. Now, we want to find the area between two curves.
Oh, ew.
So like this section.
Could you tell me the why would we need to know this? Just curious.
What?
Like what's the
it doesn't need
what's
Like
what's the word? I forgot the word. It's like
real world
yeah,
application?
real world application. There we
So
go.
you're
Let's
walking
hear this.
down a street. It's dark.
Yeah.
Lights are low.
Lights are low.
This man
Nighttime.
approaches
There's a
you
moon in the
Yeah.
sky.
and he says, I'm gonna shoot you if you don't find the area between these two curves.
Dude, that's the exact same situation I always tell people.
Right.
Yeah.
Exactly.
It's just this.
It's actually true.
I just saved your life.
Life. There we go.
So, real world application.
That's a good answer.
I mean, you got a point there.
Yeah. You never know.
Yeah.
These are the tools that you're gonna need
I
in
can start
order
making this
to.
a reality.
Yeah. I've saved you. You're welcome. Okay, so if I want the area between these two curves, then here's what you do. You find the area from the top all the way down, because you know how to do that, right? We just did that to the x-axis. Yes? Yeah? And then you find the area from the bottom curve to the x-axis. Yeah. And then you subtract them, and then you get the area that's left over in between. Easy peasy, right? Yeah? Okay, what's the area from the top of this to down? It's the integral of what? A to B of which curve? Yeah, top curve is f of x. And then what's this one? Integral A to B of g of x dx. And what you want to do is you want to subtract them, right? So the nice thing is, since the bounds are exactly the same, and you have the same top curve minus the bottom curve and they never switch, then you can combine them into one integral a to b of f of x minus g of x dx. So you can put it all in one integral, not in two separate ones. Yeah, because it's easier.
What if it's not easy?
But it is.
We just took the last couple of units learning how to split integrals. Now you're telling us just combine.
Yeah, but
That just
those
seems like a lot of waste of
those
work.
were undefined in the interval. These are defined in the interval.
What if they weren't defined?
What?
That just seems like a
You
lot of
need to
work.
learn how to separate so that you know how to come together.
That can be applied to real life too.
Yeah,
not just math.
exactly. Confucius.
It's also like biology.
Confucius says. Okay, all right. Confucius says. All right, so this still works if you find that you have two curves, one that's up here and one that's below the x-axis. It will still work because when you find the area of the top one is f of x goes from here to the x-axis. Ignore that rectangle. I don't know what that rectangle is doing in there. Okay, so you find the area of that, right? And then you find the area of g of x, which is this. But when you find the integral of g of x, it ends up being negative, right? Yeah? All right, but up here, then you're subtracting them. But when you subtract a negative, it ends up adding it back in, right? So the good thing is, you can still, doesn't matter what quadrant these two graphs are in, whether it's below the x-axis or above the x-axis, you can still just do integral from a to b. And it's always the top curve minus your bottom curve with respect to x. Okay, so it's always the top minus the bottom, as long as they don't switch in between.
What if you did bottom minus top?
Bottom minus top would just come out completely negative. It's the same number, but it would be completely negative. So, integral from 0 to 1, these are my x values. And my top curve is x squared, yep. My bottom curve is negative x. Okay? And then we just integrate. Plus 1/2 x squared from 0 to 1. And then we plug 1 in. Because I've done it like 3 times. questions?
I don't know, we should like.
No? All right, let's go to
World's number one Walmart.
this one then. Example 3. Okay, find the area of the region bounded by 2 minus x squared and the line f of x equals x. Okay, so no other restrictions on this. What's 2 minus x squared look like? Parabola. Up, down. F of x equals x is a straight line. Origin.
But now we're intersecting.
Okay, yes. So now this one doesn't tell you where you start and where you end, but it just wants everything in between, so it wants all of this area in the middle. Okay, so if it wants all of that area, we have to find the x values of the intersection. What are they? How did you find that?
I set them up.
Ah, okay, so I need to do that. That's wrong. I don't have white out. Cross it out. Set it equal to 0. Oh man. Am I boring you?
No, I'm just tired. This is very fascinating.
Yeah. You're on the edge of your seat.
It's like a movie.
This one, I had a dream that I got a 0 on FRQ.
Uh-oh.
What do you
Yeah.
dream about?
What?
You
Dream
need
about
yeah,
math?
you need better dreams.
Yeah.
That's a tough dream.
I had a dream about like winning the lottery. That was a pretty cool dream. Yeah.
That's pretty cool. But sometimes there's the lottery curse if you win.
What's that?
Yeah, what is that?
You just waste all your money.
Yeah, like
money.
everybody wants money from you, then your family.
That's what you're not supposed to say.
Relationships.
Like if you win the Powerball, you're not supposed to say your name.
I feel like when you're used to
Yeah, me too.
winning a lottery.
Okay, so we're going from -2 to 1 because those are our intersections for the x value. Which curve is on top? The,
Two minus x squared.
Yeah.
yeah. Okay. And which curve is on the bottom? The
X.
x. And then you just integrate normally. One half x squared from -2 to 1. And then we just plug in 1. 2 minus 1/3 minus 1/2 minus -2 plugged in. -4. Ooh. Plus 8/3. Minus 1/2. Yeah. Nope.
Minus 2.
2. That's it. Okay? And we don't simplify. Got it? All right, we'll stop here and then we'll go to lunch and then we'll finish the rest. And the only new thing for people that have